Good day, students. How are you doing? Welcome to class. Today, we'll be dealing with chapter 10.1, thermal expansion of solids, liquids, and gases. Let's start the class. Let's deal with temperature and temperature scales. We do that by dragging the following words into the correct boxes. To give us an idea of what temperature is, a thermometer is used to measure the temperature of hot water. Molecules of the hot water are rushing about very rapidly because the water is hot. They collide with the thermometer and share their energy with it. The bulb of the thermometer gets hotter. The thermometer's bulb and the water are at the same temperature, meaning they are at the same thermal equilibrium with one another. Energy is not being transferred from one to another. Let's check. That's correct. Let's move on. Temperature and internal energy. We are also to drag the words into the correct boxes to be able to define the relationship between temperature and internal energy. What do you think is used in measuring temperature? That's with the use of what? A thermometer. So let's start. A thermometer tells us about the average energy of the particles in the object whose temperature we are measuring. The temperature of an object is a measure of the average kinetic energy of its particles. Internal energy, on the other way, is the total energy of all the particles, while temperature is the measure of the average kinetic energy of the individual particles. For the Celsius thermometer, it has a scale of temperature known as the Celsius scale. So let's check. That's correct. So how do we design a thermometer? Mercury in glass thermometers are used in many different situations. They are attractive for a number of reasons. A. Mercury expands when heated. Marks on the scale are evenly spaced and are linear. B. The thermometer can be made sensitive by making the tube narrowly the mercury goes through it. C. Mercury thermometers have a wide range because mercury exists as a liquid between -39 degrees Celsius and +350 degrees Celsius. We are to fill in the missing words in these sentences below. Problem with, what do you think will be there? So let's put mercury. Mercury in, what will be the next missing word? Glass thermometer. Is that it has to be read by eye. Other alternatives to the mercury glass thermometer is the thermistors. and the thermocouple. So let's review the statement once again. Problem with the mercury in glass thermometer is that it has to be read by eye. Other alternatives to the mercury in glass thermometer is the thermistors and the thermocouple. Let's check for whether it is correct. That's correct. So let's deal with this past question. To mark a temperature scale on a thermometer, standard temperatures known as fixed points are needed. Which of these is a fixed point? The temperature of pure warm water. No. Room temperature. Room temperature is said to be about 25 degrees centigrade. So that is false. The temperature of a pure melting ice, that is 0 degrees centigrade. That is what? Correct, because it is a fixed point for a standard what? Thermometer that is measuring our what? Standard temperature. The temperature inside a freezer is typically less than 0 degrees Celsius. So the correct answer here is that the temperature of a pure melting ice. Let's see. That's correct. So thermal expansion. You have to define thermal expansion by dragging the following words into the correct boxes. Most substances. What do you think substances are divided into? We have solids, all right, liquids, and gases. Expand when they are heated. This notion is referred to as thermal expansion. Some types of thermometers make use of thermal expansion of a liquid. A metal bar expands when heated. When it is cold, the iron bar will just fit in the gap in the measuring device. That is when we are dealing with the expansion and the contraction of a metal bar and an iron bar. The bar is fitted, that is, it can size the space it is given. The bar is what? Fitted strongly. Now, too long to fit in the gap, it has expanded. Let's review the statement once again. Most substances, like solid, liquids, and gases, expand when they are heated. This notion is referred to as what? Thermal expansion. Let me put it back there again. All right? Some types of thermometers make use of thermal expansion of a liquid. A metal bar expands when heated. When it is cold, the iron bar will just fit in the gap in the measuring device. The bar is fitted strongly. Now, too long to fit in the gap, it has expanded. So we check. That's correct. So all these are useful expansion, except joint expansion. Yes, when dealing with a railway or a bridge that is constructed on the road. Use of bimetallic strip, such as we have in pressing iron and fire alarms. We also have riveting, the type that we have on railway tracks too. Cracking of glass tumblers due to heating. That is not what? Expansion. That is just an increase in what? Temperature that causes the what? Glass to break. When the temperature has been what? Heated. When the glass rather has been what? Heated. So the correct answer is cracking of glass tumblers due to what? Heating. That's correct. So we are also to drag the following words into the correct boxes. At first, the gas is cold and its particles press weakly on the piston. When the gas is heated, dealing with gas now, its particles move faster. Now they push with greater force on the piston and it pushes upwards. The gas has what? Expanded. The upward force of the gas is balanced by the downward weight of the piston. The pressure of the gas has remained constant as it has expanded. If the piston did not move, the volume of the gas will remain constant when it was heated, but its pressure would increase. So let's check. That's correct. So before we round it up today, let's check for the correct statement. The kinematics of an object is a measure of the average kinetic energy of its particles. Kinematics has to do with what? The direction of an object or the way an object moves. That statement is what? False. The temperature of an object is a measure of the average kinetic energy of its particles. The statement is what? Correct. This is one of the few definitions of temperature. The temperature of an object is a measure of the average potential energy of its particles. That is what? Wrong. So the correct statement here is that the temperature of an object is a measure of the average kinetic energy of its particles. Let's click and see. Correct. Now we've come to the end of today's class. Do wait to check our website www.edubbey.com for more of our interactive notes and videos. Subscribe, and subscribe. Bye, and have a great day.